Okay, so first of all, this is the lecture number third. So here we'll be understanding regarding the rank of a matrix. So how do we go about the rank of the matrix? Okay, this would be important. See, basically, what is meant by the rank of a matrix? When any matrix, like for example, you have a 3 cross 3 matrix over there, and you are going to reduce this matrix by elementary row transformations into the normal form. That means mostly you will try to make the row number third as the row of full zeros. There should be not non-zero equivalent. So if you are able to make, like in a 3 cross 3 matrix, suppose you are having A, B, C, D, E, F, G, H, I. Suppose you are going to reduce this entire row to 0, 0, 0. So the maximum rank of this matrix was 3 cross 3. If you are able to reduce this in this form, so it reduces to 2. So how this you will be doing? You will be doing using the elementary row transformations, right? For example, the first row transformation technique that I have shown you, R1 shifted to R2. Here you see R1 is basically our original matrix is this A1, A2, A3, B1, B2, B3. R1 shifted to R3 means you are just shifting the value. R1 is shifted to R2. So R1 value will go down. So R1 is going to the root 2 and R2 is going to A1. So it is just climbing. So B1 goes here, this goes here. So this is one of the matrix. Another is simply to the original matrix you are multiplying by K R3. So what happens when you are multiplying a particular row, other values don't change, it remains same. So only change will happen here. So you see only change is happening there. Another thing here is, see here I'm just changing K R1 plus R2. So the very important point here to be noted is, though you are going to multiply this scalar with R1, but R1 and R3 will not change. Only R2 will change. So this is how we are going to do a matrix transformation. Now here to be noted, the most important point is echelon form. So echelon form is somewhat of a this particular form. Now if you are making, see, this is a column, entire this thing is 0, right? And here also the column is 0 and this is 0, and same way here also this is 0 and this is 0. Either your column or the entire row value should be equal to 0. So here you see beneath the column the value is 0. Normal form of the matrix you will get by, basically this is the normal form, like this IR form. So here you see this is the identity matrix. So this is identity matrix. Only the diagonal elements are 1, 1, 1, and off diagonal elements are 0, 0, 0, 0. Okay. Or you see IR at 0. So this is your IR and this is your 0. Or you can have this as IR and 0. So this is the second form here. Or this form, right? IR and 0, 0, 0. Now, if you need to get any matrix into the this thing echelon form, so mostly the target should be to make the row of R3 to be as 0, 0, 0. Right? This should be your target. Now here you see R1, R2 and R3 is there. So let's first do an operation. Operation can be done in any which ways, which will make the mathematical computation simple. So what I do is I operate on R3. I just do R3 minus R1. So R3 value is 1 and R1 value. So 1 minus 1, right? Then 0 minus 2. Then 2 minus 1. 2 is the upper value there. And here in the R3 value is 2 minus. See, this is R3 minus R1. Na? So this is your 2 is the R3 minus R1. And then 8 minus 0. So I get a result here 0 minus 2, 1 and 8. So once I get this result, then I perform another operation 2R1 plus R. Same way, I am just multiplying to R1. So this is your 2, 4, 2 and 0, right? So 2, 4, 2 and 0, and then I'm just adding it with R1. So what I am trying to achieve is I got this particular form, right? Finally, what I do is I am targeting to get this row of 0. But if at all I don't get this entire row of 0, I will leave it as, because I'm able to at least get this column as 0, right? So either this column as 0, if I'm not able to get this column as 0, then this entire row as 0 should be my target. Now, the important question that appears in the examination repeatedly in the gate examination is regarding the rank of a matrix. Rank of a matrix is important basically for testing the consistency of any solution. Okay. Now, normally you can get the rank by reducing by row transformations. You can also do column transformations there. Okay. Now, for a 2 cross 2 matrix, the maximum rank would be 2. For a 3 cross 3 matrix, the maximum rank would be 3. Same way, 4 cross 4. But if you have a 3 cross 9 matrix, then the maximum rank would be 3. Why? Rank is the lowest of either the column or the row. For example, in 3 cross 9, see row rank and column rank is same. But as far as 3 cross 9 is concerned, lowest of the row is 3, right? So maximum would be 3. Suppose it was ulta, 9 cross 3. Again, it would have been the column rank. Okay, this is the concept that we are going to apply there. So same way, now let's see what are the type of the problems that are appearing in the gate. Okay, so what is the consistency of a equation? Okay, let's say we are having this equation in this form. So I just put this matrix. This is my A value here. A is equal to my A11, A12, and A1n. A21, A22, and A2n. Same way AM1, AM2, and AMN. Okay, this is my A value. And this is my X value. Where my X is my this value, X1, X2, and Xn. And this whole value is my B value. So I'm just writing the equation A into X is equal to my B. Okay. So in order to test the consistency, I'll take an augmented matrix A dash B. So I'll write my A values here, okay, and B values here. And then check individually the rank. This symbol row of A symbolizes the rank of A. Okay. And I'll just check rank of A is to B. Okay. Now if rank of A will be equal to rank of A is to B, and it will be equal to, for 3 cross 3 matrix, the maximum rank is 3. So if the n value is equal to 3, then this will be having a unique solution. Okay. Now if this rank is not equal to 3, suppose rank of A is also equal to rank of AB, but it is equal to 2. For a 3 cross 3 matrix, you got 2. You got an entire row 0. So that means it is then you will be having infinitely many solutions. And the third scenario is when rank of A is not equal to rank of AB, then you will be getting no solutions. Now one of the questions has appeared in the gate examination. So here you can look at this question and you can just tell me whether this solution will be having infinitely many solutions or no solution. So now you see here. If you look at here, the matrix given A is given as 1, 1, 1, minus 1, minus 1, minus 1, 0, 1, and minus 1. My target is to make this row 3 as 0. But if I look here carefully, this row 2, if I add to row 1, it becomes 0, right? Then I can shift now. I can shift row 3 to row 2. That's it. You're getting my point. So if I just add this, see, row 1, that is 1 plus, see, 1 minus 1. Then 1. This is my row 1 value. And row 1, I'm just adding to row 2. Row 2. Okay, so 1 and 1. So this minus 1, here also minus 1. So the entire thing goes to 0. And also you have to write the augmented matrix there first, right? So in order to solve this, you have to write the augmented matrix. So we had the values as 1, 1, 1, minus 1, minus 1, minus 1, 0, 1, and minus 1. And the augmented matrix there was 1 by 3, minus 1 by 3, and 0. Now this is my original matrix. This is my A is to B. What I have to see? I have to see rank of A if it is equal to rank of A is to B, and if it is equal to, see, this is a 3 cross 3 matrix. If it is equal to 3, then it will have unique solution. Correct? Unique solution. But if it is not equal, right? If rank of A is not equal to rank of A is to B, then no solution, right? Now the third scenario is if rank of A is equal to rank of A is to B, but the rank is 2, then it will have infinite solutions. Now, in the question, they have just asked us to see, first we have to reduce it to the row equivalent form, right? We have to convert it to the normal form. So I do one operation. I do this, this is my row 1, this is my row 2 over here, and this is my row 3 over there, right? So what I do is I take my row 2, right? Whichever operation I'll perform, only the value will change at that. Rest values will remain same. So I do just row 1 plus row 2. Once I do this, row 1 value is 1, 1, 1, and 1 by 3. Row 2 value is minus 1, minus 1, minus 1, and it is minus 1 by 3. If you check over here, this entire row 2 changes to 0. After this operation, I'm left with 1, 1, 1, 1 by 3, and here 0, 0, 0, 0, and here as well 0, right? This was 1 by 3, correct? 1 by 3 down here. So this is 0 over here. Okay. So then this is your 0, 1, minus 1 and 0. What I do? I just I leave it as that, or I can do like this. Row 3 shifted to row 2. Once I shift to row 2, so 1, 1, 1, 1 by 3. This is my 0. Oh, sorry. This is my this is my 0. This is my 1, minus 1 and 0 over here, and this whole row becomes 0, 0. Now see, this is my rank of A, right? This is only A part, and this is my B part over here, AB. Okay. So if I look at rank of A, one full column of 0, 0 is appearing here, right? Right, rank of A. So 0, 0. That means it is having a rank of, correct. As far as rank of A is to B is concerned, in rank of A is to B also, if I see this entire matrix, here one full column of row is appearing to be 0, right? One full row is evaluable. So rank of A and B is also equal to 2. But it is not equal to the maximum rank. The maximum rank is 3. So that means it is having infinitely many solutions. So answer to it would be infinitely many solutions. Many solutions. So this is an homework problem for you. You try this problem kindly, okay? So you'll get an answer to it. So if you solve this, then you get an idea how to do the problems. Hmm? Okay, let me stop the